Good morning. Now that we have learned all about straight line concepts and also the equations of straight lines, we're going to turn our attention to solving linear equations. And what this means when we have two straight lines is that we're trying to figure out where those straight lines cross. And coming up with that solution, there are many different methods. We're going to look today at the graphical method of solution. And then in lessons coming up, we're going to look at how we can use algebra to find the point of intersection and how we can use determinants to find the point of intersection. So we're going to start, as I say, with the graphical method. So I'm actually going to be using graph paper to draw the two straight lines, and then we'll be able to physically see where those lines cross. Okay, so we've got line 1 is 2x minus 3y is negative 5. Line 2 is 3x plus 2y is 12. Now, as you know, to draw a straight line, you need only 2 points on that line. And you can, just randomly generate 2 points. But what I'm going to do is use two very specific points. I'm going to use the X intercept and the Y intercept for each of these lines. Okay, so let's get started. We're going to fill in a chart. So when we're done, we're going to have 2 points on line 1 and 2 points on line 2. Okay, so I'm going to start with line 1, which is this equation. And I am going to begin by finding its x-intercept. Now, for an x-intercept, it is true that y is equal to 0. So that means I'm going to substitute y equals 0 into this equation. So what's that going to give us? It's going to give us 2x is negative 5. So x is negative 5 over 2. And for the purposes of graphing, it'll be nicer to write that as a mixed fraction. So we'll have negative 2 1/2 right here. Okay, it's also negative 2.5, of course. Negative 5 divided by 2 is negative 2.5. Okay, so let me just show you on here, right? In case you're really terrible with fractions, it's not really an issue because you can do negative 5 over 2, push equals, and it'll do the mixed fraction equivalent for you, negative 2 1/2. Okay? All right. So I was able to fill that in here. And now I'm going to do the same thing. I'm going to take that same equation. But now we're doing the y-intercept. And what's true of a y-intercept? X is 0. So we'll substitute x is 0 here. And you'll find that we get this. Negative 3y is negative 5. So y is negative 5 divided by negative 3. And that's the same as positive 5/3, right? And then what is that as a mixed fraction? So 5 over 3 is 1 2/3. Even if you did negative 5 over negative 3, 1 2/3. Okay, so 1 2/3 goes here in my chart. Okay, so now we have 2 points that we would plot and connect with a straight line to draw line 1. So we'll do the same thing now for line 2. So line 2 is this equation. So we'll start by finding the x-intercept. So that means setting y equal to 0. And so we will get 3x is 12 And x is 12 divided by 3, or 4. Nice to get an integer this time. Lastly, starting with line 2. But this time I would like the y-intercept. So we start by setting x equal to 0. And so this will give us 2y is 12. So y is 12 divided by 2, or 6. And then again, we would put these points on the graph and connect them with a straight line. Okay, so I'm going to show you how to do the graph now. Something that is going to be helpful here is, because I have a fraction with a denominator of 2 for an x value, when I draw my x-axis, I will put 2 squares in between every one value. And similarly here, I have a fraction and it's a y value. The denominator is 3. So I'm going to be using 3 squares as my scale for y. So let's just get started. I'll just explain that again as I go. So to begin with, I'm going to just start with some axes, okay? Like this. X and Y. All right, so now the x values, I have to make sure that I at least go to, right, -2.5 is the smallest x value, and the largest x value is 4. So if I look at the x values, I have to make sure I at least include from -2.5 to 4. And I'm gonna, again, for these x values, I'm gonna be using 2 squares as my scale. So this is what I mean, -1, -2, -3, like that. Okay, and then 1, 2, 3, 4, 5, 6, 7 I'll do. Okay, good. Now the y values, take a look at the y values. There's nothing negative, okay, which is why I didn't draw the rest of the axis down here, because there are no negative numbers. And I need to get up to 6, but remember, I've got this denominator of 3, so I'm going to use a scale of 3. So like this, 1, 2, 3, 4, 5, 6. Okay, just like that. And now I'm going to plot my points. So it'd be nice if we could see, if I go like that, I want to make sure everything's going to be on the screen. Yeah, that'll work. Okay, so I've got the chart at the bottom. I'm going to plot these points now. So let's do line 1, -2.5, 0. So -2.5, 0 is right there. And also for line 1, 0 and 1 2/3. 0 and 1. Now 2/3 will be 2 more squares right here. That's the point. 0, 1 2/3. Okay, so I would be connecting that with a straight line. Okay, so make sure you get right in the corner of the squares. This has to be done super carefully. Oh, I put this dot in the wrong spot. Did you guys notice that? That's supposed to be -2.5. And where did I put it? At -1.5. Can I just fix that? You don't want me to do the whole video over, do you? Let's just go like that. -2.5, 0. So sorry. And now 0, 1 2/3. Okay. So I need to, and I was just saying how careful I had to be. Okay, so here, there we go. That is line 1. Okay, now let's do line 2. So 4, 0, right there. 0, 6 is right here. And so now I have to connect those two with a straight line. Okay, make sure you get the corner of the squares. Okay, just like that. Beautiful. So that is line 2, line 2. So what is the solution of this linear system? The solution is the point of intersection. Where do they cross? They cross right here. That is the point 2, 3. You see, 2 to the right and 3 up. So 2, 3 is called the point of intersection, and it's also the solution for the system. Okay, so back to our page here, we could say 2, 3 is the intersection point. We could also say that 2, 3 is the solution for the system. So I'll put the graph there one more time for you to have a good look at it. Okay, so this is the x-intercept of line 1 at -2 1/2. This is the y-intercept for line 1 at 1 2/3. This is the x-intercept for line 2 at 4, and the y-intercept of line 2 at 6. And here the lines cross at the point 2, 3. All right, let's do one more example together. So I've got a second one set up for us here. So we'll do the exact same thing, filling in the chart with the 4 points and then doing the sketch. So here we go. Line 1 is x minus 4y is 6. Line 2, x minus 2y is -4. And I'm going to do it the same way as last time. So I'm going to start with the equation for line 1, and I'm going to start by finding the x-intercept, which means start by substituting y equals 0. So x minus 4 times 0 is 6. So that, of course, will be x minus 0 is 6. X is 6. So I can write that here. Start with the exact same straight line equation, but now we want the y-intercept, so we substitute x equals 0. So 0 minus 4y is 6. If -4y is 6, then y is 6 over -4. Okay, so, 6 divided by -4, of course, is -1.5. But remember, I've been trying to use fractions so that our graphs are perfect. So hit the fraction button and you get -1 and 1/2. Okay, and you could have done it this way as well. 6 over -4 is -1 and 1/2. That's our nice mixed fraction. Okay, and now we go on to the second straight line. So here is the second straight line equation. And we're going to do the x-intercept first. So we're going to substitute y equals 0. So that's x minus 0 is -4. So x is -4. Nice integer results here. Back to that same straight line equation, but now we want the y-intercept, so we will substitute x equals 0. So if -2y is -4, then y is -4 divided by -2, y is 2. And that goes here. Okay, so I will once again draw the accompanying diagram for you. And when I do this graph, I'm going to use as my scale for y 2 squares, because again, I have a fraction for y, its denominator is 2. So to make my graph super accurate, I'm going to use 2 squares as my scale for y. So let's get started on my graph. So I'm going to start by making these axes. Okay, so I'm going to say that that's x and y respectively. And then for x, we didn't have any fractions. So I'm just going to, use a scale of 1 for x. Okay, so this is 1, 2, 3, and so on. Okay, so the scale is 1. My x values are 6 and -4. So I'll make sure I go to at least that for now. 3, 4, 5, 6, and -1, 2, 3, 4. Okay, but we did have a fraction for y, so my scale is going to be 2 for y. And the y values, I have to make sure I get up to at least 2, so it's like, 1, 2. See, scale of 2. And then, -1, -2. Okay, like that. And now I'll do that. I'll make sure we can see both at once. The graph, yeah. Okay, the graph and the chart. And we're going to start by plotting the 4 points. So for line 1, the x-intercept is right here at 6. The y-intercept is -1 and 1/2. So that's -1, -1 and 1/2 is right there. Okay. Now for so line 1 is formed by connecting those 2 points. All right, so I'm gonna do that. I'm cheating a bit because I know what the point of intersection is going to be. Haha. Sorry, guys. Okay, there we go. That's perfect. And then I'm going to do for line 2. So -4 is the x-intercept right there. The y-intercept is +2 right there. So I need to connect those 2 with a straight line also. Okay. This one could have gone a little further. So this question is really difficult to do with a graph because you see the point of intersection is way over here, well outside the domain and range of the x and y intercepts. Okay, but they do indeed cross way over here at the very edge of your screen there. So let's write down the points here. So let's negative 4, negative 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So negative 14 is here, right there. Okay, and then down here, where are we? This is negative 2, negative 3, negative 4, negative 5. Okay, so at negative 14, negative 5, that is the point of intersection, and it is also considered to be the solution of the system. Okay, so back to our paper, we could conclude that negative 14, negative 5 is the solution or the intersection point. Now, one thing that I should talk about is the fact that you can check this answer. How do you check that this is the solution? Well, you can substitute into both of the original equations to ensure that left and right sides come out equal. So here's what I mean. We have x minus 4y is 6. We can substitute x is negative 14 and y is negative 5. And then if we did that, we'd get negative 14 plus 20 is 6. 6 is 6. And now that only verifies that this point is on the first line. So we have to also verify that it is on the second line. So this is the second line equation. Substitute x is negative 14. Substitute y is negative 5. And what do we get? We get negative 14 plus 10 is negative 4. And that is a true statement also. So we have just verified that this indeed satisfies both equations and therefore must be the point of intersection. Okay, I'll show you the graph one more time. I didn't label line 1 and line 2, right? So line 1 is this one right here. So line 1 had an x-intercept of 6 and a y-intercept of negative 1 and 1/2. Line 2 had an x-intercept of negative 4 and a y-intercept of 2. The straight lines do indeed cross, but way the heck over here at negative 14, negative 5. Okay, I hope you understood that lesson today. There are a couple questions you can try. You 100% need graph paper to do these. If you don't have graph paper at home, I did put a template from the internet right inside your Module 3 folder. Okay, have a great day.